Hello, young math padawans. It's Mrs. Angel with today's lesson on properties of exponents, hopefully a review. So in this lesson, we're only going to be looking into three of the properties: the product of powers, the quotient of powers, and the power of powers. And all three, we're going to be working at expanding and simplifying, looking at what's required to use each property. So grab your notes and let's get started. So the first property of exponents is called a product of powers. A product of powers is telling you what you're looking at. This is an expression when you are multiplying, because that's what a product is, two or more powers. Now, there is another key here to product of powers that we will get into in this exploration. So if we look at our first example here, we have 2 to the power of 3 times 2 to the power of 4. So our steps for simplifying using properties of exponents are pretty simple. First, we're going to expand the powers into products, and then we're going to simplify and write it as what's called a single power. Let me show you what I mean in the first example. So 2 to the power of 3. This is the first power in our product. We're going to start by expanding that. 2 to the power of 3 means 2 times 2 times 2, or in other words, 2 multiplied by itself 3 times. We're going to continue that multiplication by multiplying it by 2 to the power of 4. So notice how I'm continuing on that multiplication. I'm bringing this multiplication sign with me. Then I'm going to expand 2 to the power of 4, which is 2 times 2 times 2 times 2. That's called expanding. In other words, take the power and write it as a product. Now to simplify, I don't mean go in there and actually multiply all of those 2s. 2 times 2 is 4, times 2 is 8, etc. That just means take all these 2s and write it as a single power. So if you pay attention here, we're multiplying 2 by itself continuously. How many times? Well, 1, 2, 3, 4, 5, 6, and 7. So this could be written as a single power, as 2, base 2, to the power of 7. And that's what applying the properties of exponents actually means. How many times are you multiplying that base by itself? Let's look at our next example. X to the power of 5 times x to the power of 2. We're going to start by expanding. Start with the first power. X to the power of 5 is x multiplied by itself 5 times. Now we're continuing on that multiplication because this is a product of powers. X to the power of 2 is x multiplied by itself 2 times. Notice how now we have a product where we're multiplying x by itself many times. Well, how many times? Well, there's 5 in the first and 2 more. That makes a grand total of 7. So to write this as a single power, it would be x to the power of 7, just like we had 2 to the power of 7. How many total times are you multiplying x by itself? Why don't you try the third one on your own now? Okay, let's go in and count. How many total times am I multiplying y? Well, we have 1, 2, 3, 4, 5, 6 total times. So as a single power, that would be y to the power of 6. Now, all three of these examples have something in common. You're multiplying powers that have the same base. Notice I have 2's, x's, and y's. Well, what happens when I try to multiply powers that have different bases? Let's see in our next example. In our final example, in our product of powers, we have x to the power of 5. So we're going to write that out. That's x multiplied by itself 5 times. X times x times x times x times x. Now we're continuing on that multiplication, but this time we're doing it with y. So times y times y times y. But we're multiplying two different numbers. So you can't write a product as a single power unless you're continuing on multiplication with the same base. So because these are two different bases, I have to keep these as two separate powers. In other words, there actually is no simplifying that can be done here. I have 5 x's, which is x to the power of 5, and I've got 3 y's, which is y to the power of 3. So the product of powers allows you to multiply 2 or more powers and simplify them into a single power as long as they have the same base. And that is an important key to note. If they do not have the same base, There's no way that you can simplify or write them as a single power. You just have nothing that you can do. Up next is the quotient of powers. So the quotient of powers tells you what you're looking at. You're looking at dividing two or more powers. And again, what happens when we actually go in and try to divide? Well, we're going to follow the same idea as the product of powers. We're going to expand and we're going to simplify. Now, because we're working with quotients, I am going to start by drawing in a fraction bar because we are dealing with numerators and denominators here. Now let's expand the numerator. 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. 2 multiplied by itself 5 times. Let's expand the denominator. 2 to the power of 3 is 2 times 2 times 2, or 2 multiplied by itself 3 times. Well, I'm not continuing on multiplication, so I can't simplify in that sense. But what can I do? Well, with quotients, you look for big ones, which is the same number in the numerator and the denominator. In other words, what's 2 divided by 2? That would just be 1. So how many big ones do I see? Well, I see 2 divided by 2, that's a big one. Another 2 divided by 2, that's another big one. And another 2 divided by 2, which makes a third big one. So what does that leave me with? That leaves me with 2 times 2 in the numerator, and everything in the denominator has simplified to 1. So I'm just left with 1 in the denominator. So now let's simplify what we have left. In our numerator, we have 2 to the power of 2, so that's 2 times 2. And in our denominator, we have that placeholder 1. Now, can I simplify a fraction if it's put over 1? Yeah, any fraction over 1 is just a whole number. So I could just write that as 2 to the power of 2, and this is a simplified power. Notice how I'm not multiplying and saying that's also 4. To simplify with properties just means to write it as a single power. Let's try our second example. Again, we're working with quotients, so I'm going to start with a fraction bar. And let's expand our first power. We have x to the power of 4, which is x multiplied by itself 4 times x times x times x times x. Now we're going to we're going to expand x to the power of 6. 1, 2, 3, 4, 5, 6. And again, in quotients, we're looking for those big ones. How many big ones do you see in this quotient? I see, well, let's count what I see. I see x divided by x, which is 1. X divided by x, which is another 1. Another 1, and a third 1. So there are 4 big ones here. I'm left with x times x in the denominator and a placeholder 1 in the numerator. So let's write this as a single power. In the numerator, I have 1, and in the denominator, I have x times x, which is just x to the power of 2. Now, question, can I write that as just x to the power of 2? No, that 1 is in the numerator. So that means that 1 stays in the numerator. There is no simplifying that I can do here. That is just going to remain a fraction. Why don't you try the third one on your own? Now we look for our big ones. M divided by n, m divided by n, and m divided by m, which leaves us with a placeholder 1 in the numerator. Let's write it as a single power. Set up your fraction. What's left in the numerator? Just 1. And in the denominator, we have m times m times m, which is m to the third power. Can I also write that as m to the power of 3? No. A 1 in the numerator cannot be simplified. That means that your answer has to remain a fraction. Now let's look what happens when you have a quotient of powers with different bases, like we do in our final example. In the numerator, we have x squared. That's x times x. And in the denominator, we have y to the power of 3. Y times y times y. Now, does x divided by y equal 1? No. Only the same number divided by itself equals 1. And x and y are not the same numbers. So is there anything we can simplify here? No. Just like our product of powers, we can't do anything unless we have the same base. So this would just remain x squared in the numerator and y cubed in the denominator. In other words, this can't be simplified. So to add on to our original definition of quotient of powers means to divide 2 or more powers, which again have the same base. Because without a same base, you can't go in there and make those big ones. Our final property is called the power of powers, and this one is by far one of the tougher ones of the three. So power of powers is exactly what it sounds like. You are looking at a power raised to another power. So you're going to see two exponents. In other words, you're going to see a base, and then you're going to see two exponents almost next to each other. But the rules remain the same. You expand the powers, and then you simplify. So when we come to powers of powers, I like to work from the outside in. So that means I'm looking at this first one, 2 to the power 3 to the power, 2 to the power 2 to the power 3. I'm looking at it just as something to the power of 3. So I'm going to start by expanding just the power of 3. Let me show you what I mean. So this will be done in 2 steps. Step 1, I'm going to take my 2 to the power of 2 and multiply that by itself 3 times. So that would be 2 to the power of 2 times 2 to the power of 2 times 2 to the power of 2. So notice now I've gotten rid of that power of 3. Now in the second step, I can go in and expand all of my inside powers, that 2 to the power of 2. That's just 2 times 2. So 2 to the power of 2 is 2 times 2 times. Notice that I'm just continuing on that multiplication. 2 times 2 times. Continuing on that multiplication. 2 times 2. So I work outside in. Now we just count up how many total times we're multiplying 2 by itself. I see a total of 6, so this simplifies to 2 to the power of 6. Let's try our next example. So again, I work outside in. I'm looking at something to the power of 2. What is it to the power of 2? It looks like we're going to be multiplying m to the power of 5 twice. So step 1, let's expand that first power. That's m to the power of 5 times m to the power of 5. Notice here that after you complete step 1, this just becomes a product of powers. Now I'm just multiplying 2 powers. Let's expand. M to the power of 5 is 5m. 3, 4, 5. There's your first power times your second power. 1, 2, 3, 4, 5. All right. Now that we're fully expanded, we can simplify. How many total times am I multiplying m? I've got 5 in the first and 5 in the second. That makes a total of m to the power of 10. Why don't you try example 3, r to the power of 2 to the power of 4 on your own now. Okay, now that we're fully expanded, let's figure out how many r's there are. That's kind of a weird way of saying it. We've got 1, 2, 3, 4, 5, 6, 7, 8. So this as a single power would be r to the power of 8. Now, as we did with our previous examples, we're going to see if we can still use powers of powers with different bases. And in our last example, we have that. Working again from outward in, we're dealing with a power of 3, and our base appears to be xy. So now we have 2 different bases. Let's see if it makes a difference. Step 1, we expand. That's just xy times xy times xy. Now, xy just means x times y. So I'm actually going to zoom in here and put in a placeholder multiplication sign, and then I'm also going to put in that multiplication sign in my expanded part as well. So anytime you see 2 variables together, that just means that you're multiplying those variables. xy means x times y. Now there's actually some simplifying I can do here, but I'm going to apply what's called the commutative property of multiplication, which means if you have multiplication, you can reorder all of the factors however you like. So the way that I'm going to reorder it is I'm going to bring all my x's next to each other and then all my y's next to each other, because you can only simplify products that have the same base. So in step 2 here, I'm going to bring my 3 x's, x times x times x, to the front. And you could have put y to the front, but we tend to like doing things in alphabetical order, times my 3 y's, y times y times y. And is there some simplifying I can do here? Absolutely. X times x times x is just x to the power of 3. And y times y times y is y to the power of 3. So this actually could be simplified. So a power of a power is any power raised to an additional power, regardless of what base you have. In other words, you don't have to have the same base. Let's recap. So whenever you're dealing with properties of exponents, your two steps are to expand and simplify. And simplify means to write it as a single power. So that doesn't mean actually going in there and doing that multiplication. Just take that messy power expression and write it as one single power. In a product of powers, which means you are multiplying, to simplify, they must have the same base. If they have different bases, you cannot simplify, write them as a single power. In a quotient of powers, where you are dividing two powers, they must also have the same base. Without the same base, you cannot simplify. And then in that case, you're also looking for those big ones, same number in the numerator and denominator. Finally, in a power of powers, any base is fine, but make sure that you are working outside in. You start with the outside exponent and expanding the first power, then go in and expand what's inside the parentheses. That's it for today's lesson. I will see you next time.